previous session we discussed about the introduction to the magnetic field, the force on a charge due to the magnetic field, and the direction of magnetic field. Okay, now here in this session we start our topic, the unit of magnetic field. So first we write the equation of force due to the equation of force on a charge due to the magnetic field. What is this equation? So force on a means magnetic force on a charge particle. Okay, what is this magnetic force? Fm is equal to Q into V cross B. This is the equation of magnetic force. Okay, if you write this answer in terms of magnitude, then F is equal to QVB sin theta. Okay, as we discussed about this equation in the last session, what is this? For this is the force on the positive charge. Okay, so put the value of Q with a sign, positive or negative. So here this equation gives us the force on a positive charge. If negative charge is given to you, then this negative sign is used here and the direction is opposite to this one. Means the force on a positive charge and force on a negative charge by the magnetic field is opposite to each other. Okay, because यहाँ पे minus sign आ जाएगी, so that's opposite to each other. So this is what force on charge Q. Okay, where Q is put with sign. Here Q is put with sign. That is the first note. Second note is what? This forces depends V and B, means direction force is perpendicular to V and this plane formed by the V and B. Okay, so Fm is perpendicular to the plane formed by V and B. That is second one. And this next one, if velocity is equal to 0, if velocity is equal to 0 or velocity parallel to B or anti-parallel to B, both case, parallel or anti-parallel, this means theta is equal to 0 or pi in this both case, and this both case Fm is equal to 0. Fm is equal to what? 0. That is the symbol. If V is equal to 0 or V parallel to B, then Fm is equal to 0. That is the one some simple notes which we have to write for the magnetic force. Now let me derive the unit of a magnetic field. Up to this we are discuss about the magnetic force, direction of magnetic field, everything, but we are not discuss anything about the unit. How to derive the unit? So from this equation, how to write the unit of magnetic field? So find the B from here. So unit of B is equal to unit of F upon QV. Actually we not consider sin theta. Sin theta means this one is a unitless term, so only consider the F upon QV. That is the unit. So what is the unit of F? So unit of F is Newton. What is the unit of Q? So unit of Q is a Coulomb. Unit of Q is what? Coulomb. What is the unit of velocity? Velocity means मीटर पर सेकेंड. आप इसको मतलब कूलम को चेंज कर लो यहाँ पे तो भी नया आंसर मिल जाएगा. सो इट इज इक्वल टू न्यूटन अपॉन कूलम इज एम्पियर इनटू सेकेंड. Q is equal to I into T. So Coulomb is equal to what? Ampere into second. So ampere into second, meter per second. So second cancel out. So finally you get this answer, Newton per ampere into meter. That is the unit of magnetic field. But generally we are not use this unit to represent this magnetic field. We are use the unit for the magnetic field is the Tesla. So this is represents a 1 Tesla. 1 Newton per ampere meter, that's called a 1 Tesla. So generally well-known, that's a unit of magnetic field, but this unit is replaced by Tesla. Okay, and generally is denoted by capital T. It is denoted by capital T. So unit of magnetic field is what? Tesla. Okay, and 1 Tesla is equal to 1 Newton per ampere into meter. And dimensional formula you just write by yourself, homework. डायमेंशनल फॉर्मूला, दिस इज इन होमवर्क, ठीक है। होमवर्क में आप डायमेंशनल फॉर्मूला इक्वेशन से बना लेना। दैट इज द यूनिट ऑफ मैग्नेटिक फील्ड एंड यू मस्ट बी रिमेंबर। अनदर यूनिट इज यूज्ड फॉर द मैग्नेटिक फील्ड, दैट्स अ गोस, okay। So Tesla is a larger unit. Tesla is what? Larger unit. So smaller unit is used. So Gauss is another unit of magnetic field. So unit of magnetic field, another, okay, and that is what Gauss. So 1 Tesla is equal to 10 to the power Gauss. Sorry, 4 power Gauss. This is the relation between the Tesla and the Gauss. Gauss is represented by the capital G and Tesla is represented by the capital T. So 1 Tesla is equal to 10 raised to 4 Gauss, or you just write in opposite term, 1 Gauss is equal to 10 raised to minus 4 Tesla. This both are same actually. If you consider Tesla to Gauss or Gauss to Tesla, then use this relation, and we have to use this relation in a different examples. So all of you must be remember this relation. 1 Tesla is equal to 10 raised to 4 Gauss and 1 Gauss is equal to 10 raised to 4 Tesla. Tesla is denoted by capital T and Gauss is denoted by capital G. So this both units for the magnetic field generally used in examples. Okay, we are not use this unit. Actually this is called 1 Tesla, this or this one also, this is called a 1 Tesla, but we represent the always unit of magnetic field by the T or by the G. G means Gauss, T means Tesla. Okay, all of you guys note this one in your books, and after we are go to this next one. Okay guys, comes to this next one. The force on a current carrying conductor means magnetic force. Actually we have to discuss about the magnetic force on a current carrying element means conductor. Because suppose it is a magnetic field, uniform magnetic field. If it is not, then we discuss about it, means we write the equation if this is not constant, if it is not uniform. Okay, now you just consider any conductor having a length L and the cross section area A is put into this magnetic field. Now initially there is nothing is passing through this one. Now you connect this conductor with a battery. Suppose you consider this conductor is connected to the battery. So due to this one, some current is flow through it. Suppose you consider the I current is flow through this conductor. So how much current will flow? I. So current is flow means electrons are flow, means electrons are moving with some speed Vd. If see initially electrons are supposed to be at rest, so if any charge is at rest, then force to the magnetic field is what? 0. But now if you connect this conductor to the battery, so some current is flow through this conductor. If the current is flow through the conductor, that means the charge means electrons, the free electrons are move with the Vd. Vd means drift velocity, as we know, we studied about it in a current electricity. So all those electrons, whatever is present inside this one, are moving with the Vd. If electrons are moving, means charges are moving. If the charges are moving, it means that is some force is produced, okay, on the charges. So we have to find whatever the force is produced on the whole charges equal to the force on the conductor. We write this one. So first we just find the number of electron inside this conductor. So let's we find the total charge inside the conductor. So first of all, means current passing through the conductor, it means the electrons are moving with the drift velocity. Okay, so here we write this one, whole electrons are moving with drift velocity. Here we consider this type of situation, all electrons are moving with the drift velocity. Okay, it's meant the how many electrons are present? So total number of electrons, total number of actually charge carrier, total number of charge carrier. So n is equal to n into volume. Yes or no? So total number of electrons is equal to n means what? The number of electron per unit volume. So multiply by its volume. So it means it is the total number of electron, total number of charge carrier. So its answer is what? N into what is the volume of this conductor? So cross sectional area is A. Consider the cross sectional area is equal to N. Length is L. So it's equal to what? N into A into L. So that is the total number of charge carrier which is present inside this one. Means what is the total number of total charge inside this one? So total charge is a q, and q is equal to Ne, as we know. So N is this one and E is the charge. So what is the force on charge is given by Fm is equal to Q V cross B. Fm, this is the original equation. Now we put the all values here. So what is total Q? Total Q is a total number of charge carrier multiplied by E. So total number of charge carrier NaL. Total number of charge carrier N into A into L. So NaL. Okay. NaL into E actually. This is only number of charge carrier multiplied by E, that is the total charge, into V is replaced by all electrons are moving with a drift velocity. Drift velocity means what? Vd. So V is replaced by Vd cross B like this. Okay, you just change this vector sign to this one. This Vd and length both are along the same one. If you consider this is the length, then this is the Vd. Both have a same direction. So you change the vector and you forming a new equation NaEVd into L cross B. Means you gives the vector sign of Vd to the L because both have a same direction. See, L is this one, Vd is this one. If conductor like this, L is this one, Vd is this one. Means both are same. So you just change this sign like this. So what is NaEVd? This is the equation of current. I is equal to NaEVd from the current electricity. If you consider any conductor and the current flows through it, then current is given by NaEVd. So here this equation of this magnetic force is becomes IL cross B. This equation is becomes IL cross B. Where what is IL? Actually this whatever this direction of this current is flowing, that's represent the L. Okay, if electrons are moving, as we know, if electrons are always moving is up in opposite direction to the external electric field. We know about this one. Electrons and current direction is what? Opposite to the electron. Current direction is what? Opposite to the electron. So we are consider this positive sign here only. Okay, current direction. This is represents the current direction. This is the representation of a current direction. But current we are not giving the direction of the current, so we are giving the direction of the length. Actually, but otherwise it is represented like this current direction. It's called a current element. We call it is current element. So here we use only positive sign. See, because in whatever the direction of electrons are moving, this current is always considered opposite to the electron movement. If electrons are moving opposite to the external electric field, it means we consider the current is flowing in the direction of electric field. So here we use the only positive sign, and the final answer of this one, Fm is equal to IL cross B. So this is the force on the element. If it is not uniform, see, conductor is not uniform, then what? Then we are integrate system. We are find the small force on a small element like this. If it is non-uniform, then what? See, with the thus both are possible, non-uniform conductor or non-uniform magnetic force. That is both possibility. So at that time we use the same equation but in an integration format. Okay, so let's we consider this one. If non-uniform conductor or magnetic field is given, then forces given by like this. See, you consider this type of non-uniform magnetic field, we don't know. This is non-uniform magnetic field, and in this non-uniform magnetic field, you consider, suppose you just place any conductor like this. Okay, what is this? This is a non-uniform conductor. Okay, non-uniform magnetic field. So you here you consider only small element. You consider any small element dl. Consider any small. Actually, the current is passed through. This is I. Then we generally write this is the current element, and that is called IDL. Consider it is IDL. Okay, and here this magnetic field is which one? This, suppose here in this situation magnetic field is like this B. So within this small element maybe we consider the magnetic field is constant. So how we write this equation of df on the element? So force on an element, it's given by dfm is equal to IDL cross B, like this. This equation is written in this format. When this conductor is non-uniform or magnetic field is non-uniform, so at that time we just write this equation, the force on a small element. Okay, so this force is given by, means here we write this force on small current carrying element. Actually we call it is current element. Okay, small current element. Then this equation, if you want a total force, then what are you doing here? Then total force Fm is given by integration of this equation. So integration IDL cross B. So this is our answer. Integration IDL cross B. If you consider this summation, then no problem. If you consider delta, then you write the same equation in this format also. Fm is equal to sigma I delta L cross B. This both equations are correct actually. This one is in integration form, this one is in sigma form. But generally we know by the integration we have some equations for this non-uniform case. At that time we always use the integration. So you must be remember this format. Okay, now whenever this type of situation is given, if your this magnetic field is uniform, if magnetic field is uniform, only this one is non-uniform, then what are you doing? What you have to do? Okay, if only this conductor is non-uniform, means it is its length is not a straight, maybe circle, maybe triangle, whatever that's given to you, then you must be write this equation in this format. For uniform magnetic field, you just write this topic in additional notes. For only for uniform magnetic field. Magnetic field is uniform. Magnetic field is what? Uniform. If you place any non-uniform conductor in a uniform magnetic field, then what happens? See, suppose it is magnetic field. What is this? Magnetic field. You place any conductor inside this one which is non-uniform, like this. Okay, but drawing is not proper. I am drawing this again. See, it is a non-uniform, suppose. So consider that's the initial point and that's a final point. Okay, so here you take the small components. Here you take the small components of this one. Then let's choose the small components here. Suppose it is your small components. Here we consider the small length dl. Here we consider the small length dl. Then dl having a two components. First one is a horizontal. Second one is a vertical. Horizontal is supposed to be dx and vertical is supposed to be dy. So here there's always summation of dx, 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 dy. Then finally you get this length. This along is a summation of dx and this one is a summation of dy. Suppose we consider this horizontal direction is x and vertical direction is y. Then summation of dx, dx, dx is what? That's total x, and summation of dy is what? Total y in vertical. This is our movement. Okay, so if you have to use this equation, if you use this equation, then there is a force along x and force along y. You get this two answer. So Fm along x and Fm along y. So here the cross product is present. See, dl cross b. dl means what? Here what is the dl? dl is equal to dx plus dy, dx plus dy, two components. So if you put this value here, then what is the force? Then this is displacement vector. Okay, then what is the force? So force is given by Fm is equal to integration I. dl is replaced by dx plus dy. dx plus dy cross b, like this. Yes or no? But see, dx and b both are in the same direction. dx and b both are in a same direction, so cross product is 0. But dy and b both are not in the same direction, thus both are perpendicular to each other, so there is a cross product is not a 0. Okay, so for dx cross b is 0, only dy is considered. So for non-uniform length, whenever this type of case is given to you, only for uniform magnetic field, always consider this parallel, means force on a parallel component is 0. Only consider the perpendicular component. So here from this equation we write down this answer: dx cross b is a 0, and this one dy cross b means dy cross b is not equal to 0. So this is our final answer. In this situation, if any non-uniform length is given to you, you consider the only perpendicular length from initial point to final point. Then your answer is what? For this one, what is your answer? Fm is equal to, actually we write only magnitude, I into L perpendicular into B. This is your answer. If any cross section, any conductor is given in this format, then Fm is equal to I into L perpendicular into B. Okay, here you only use the perpendicular length, because the force on parallel length is becomes 0. dx cross b is 0. It means force on parallel length is 0. Only you consider the perpendicular. If a closed loop is given to you, then what? Then integration dl is 0. If closed loop is given to you, then what? Integration dl is 0 for any closed loop. अगर आप ऐसे कोई closed loop रखते हो तो dl वेक्टर फॉर्म में तो 0 हो जाएगा. यहाँ पे समेशन तो वेक्टर का ही है. So integration dl is always 0 for a closed loop. So force on a closed loop by the magnetic field is always 0. Force on a closed loop by the, see, must be considered uniform magnetic, huh? If it is non-uniform, then not. But uniform magnetic field is given. We discuss this case only for uniform magnetic. If any conductor is placed in a uniform magnetic field, then you use this equation. Fm is equal to I into, this is a magnitude. Direction आप right hand thumb rule का use करके find कर सकते हो. That is what magnitude. So here this is magnitude. And for direction, use right hand thumb rule. ओके अगर इस केस में मुझे डायरेक्शन चाहिए तो क्या करना होगा? देखो यहाँ पे सिंपल है. दैट्स अ वर्टिकल कंपोनेंट्स फ्रॉम इनिशियल टू फाइनल. सो x plus y. So this is your y, means that is your L perpendicular. Okay, and here it is B. So that is a B. And cross product is from L to B. So arrange your right hand parallel to L. Okay, arrange your right hand parallel to L. Curl your fingers towards the B. So curl your finger towards the B. So thumb is inside. So here the force on the element is perpendicular to this plane, and that is going into. That is what going into the plane. So this is the direction of force. So for the direction, use the right hand thumb rule. Right now again I am telling to you that is this one is a vertical perpendicular components of this one, because parallel component में the force 0 रहेगा. तो perpendicular components हुआ और ये B हुआ ऐसे. Okay, so arrange your right hand parallel to the first quantity. First quantity यहाँ पे कौन है? L. So L को parallel arrange करो. Curl your fingers towards the second quantity. What is the second quantity here? B. So curl your fingers. So your thumb is the direction of force. Your thumb is what? Direction of force. So in this situation, the force on this element is perpendicular to the plane and it is going into the plane. So this is the direction of force in this situation. So for direction, use right hand thumb rule, and here you write one special notes. Okay, this one actually ये नोट्स में ही लिखना है आपको. Force on a closed loop. Force on closed loop in uniform magnetic field is always 0. बट कैसी क्लोज लूप होनी चाहिए? करंट कैरिंग क्लोज लूप. फोर्स ऑन अ करंट कैरिंग क्लोज लूप. करंट कैरिंग क्लोज लूप इन यूनिफॉर्म मैग्नेटिक फील्ड इज ऑलवेज 0. क्यों? ओके, इस केस में आपका इंटीग्रेशन dl 0 हो जाएगा. If you consider dl plus dl plus dl, that's dl, that's dl, that's dl, 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 any type of length is given to you, then vector sum of this one is what? Always 0, because closed loop. Initial point is equal to final point. Initial point is equal to what? Final point. यहाँ पे initial point and final point same होगा closed loop में. तो vector sum आपका कैसा होगा? Displacement का 0. ओके, जहाँ से आपने स्टार्ट किया वहीं पे वापस मतलब displacement 0. So here displacement vector is also means summation of total net displacement is 0. So here we write the answer. Thus force on a current carrying closed loop, फिर से closed loop in a uniform. So you must be not this one in your books to solve out the different MCQs if it is given to you. Okay, a simple equation का यूज करके आप पूरा प्रॉब्लम जो है सॉल्व कर सकते हो, डायरेक्टली आपको आंसर मिल जाएगा. ओके, तो थ्योरी आपको अच्छी तरह से याद रखनी और एडिशनल नोट्स आपके लिए MCQ रहे. तो पूरा टॉपिक आप बुक्स में नोट्स कर लो. Now come to this example section, magnetic field and force. First we solve this textbook example, illustration number 4.1. What is the problem statement? A straight wire of mass 200 gram. So mass m is given to us. So that is equal to what? 200 gram. Length is 1.5 meter. So length L is equal to 1.5 meter. Carries a current of 2 ampere. So current I is equal to what? 2 ampere. It is suspended in a mid-air by the uniform magnetic field B as shown in figure. Means this is the wire, and it's some magnetic field B is applied over here. So this wire is suspended, means net force on the wire is what? 0. Then what is the magnitude of this magnetic field? So we have to finding out the value of B is equal to what? If this wire is suspended, then what happened here? See, there is must be this one force is applied in downward direction. Which one? mg. So mg is always in the downward direction. Now B is going into the plane. I is like this one. This figure is given to us. Now what is the direction? If this wire is suspended into there, it means mg must be balanced by the another force. And here only one possibility of the force which is produced by this magnetic field. So if you consider this situation, then there is a direction of I. Means this is the IL. This is the direction of IL, and this is in going into this is B. So here this one is given to us, IDL and B. Okay, so what is the force? IDL cross B means IL into B. So what is the direction of magnetic force here? So first use the right hand thumb rule. Arrange your right hand parallel to the IL. So this is IL, parallel to IL. Curl your fingers towards the B. So ऐसे finger curl करो. This is the upward direction. So here in this situation, this mg is balanced by Fm. Okay. Second thing, the angle between the IL and B. So IL is along the right hand side like this, and B is this one. So what is this angle? 90 degree. So here this angle between the IL and B is 90 degree. If theta is equal to 90 degree, then magnetic force is given by ILB sin 90. Sin 90 is always 1. So magnetic force is given by ILB, and this force is balanced by mg. So in equilibrium we can write down this mg is equal to what? ILB means actual FM is equal to ILB right in this present situation. So what is this B from here? So B is equal to mg upon IL. You put all this value in SI unit. So you convert this 200 gram means what? 0.2 kg, 1.5 meter to ampere. This all are correct. Now you put the all value into this equation and find B. Okay, remaining calculation is in homework. Okay, so this very simple example which is given in a textbook. You just using this concept of the magnetic force, which is balance the mg of this wire, and you get the answer. Okay, चलो example को note करो. Okay, now comes to the illustration number 4.2. Now what is the problem statement? Actually this type of figure is given to us, x, y and z axis. Here x, y is going into the plane and z, and the B is parallel to the y. So y is going into and B is also going into. So this type of situation is given to us. Now we have to find the direction of force. We have to find the direction of force on electron and on proton. Direction of force on electron and proton when thus both are projected along x-axis. So here we use the only right hand thumb rule. So okay, for the both cases, right hand thumb rule we have to use. First we find the force on electron actually. So force on electron, case 1, force on electron. So what is this force? Fm is equal to, actually what is this force? Fm is equal to Q V cross B. So Fm is equal to Q. Q means minus electron means minus E, means we put the Q with the sign. Okay. So in this case minus E into V cross B. Here you use the unit vector, no problem. Use the right hand thumb rule, no problem. Okay. So let's first we use the right hand thumb rule. Right hand thumb rule. We have to find the direction of minus V cross B. First V cross B find करो, उसको minus sign apply करो, then you get the final answer of the force. So where is the V? V is along x-axis. So V is along x-axis. B is going into the plane, so B is going into the plane. So this type of situation actually x and y. Now V cross B. So V is x. So arrange your right hand parallel to this x-axis. Curl your fingers towards the y, means towards the B. So your thumb is upward. So that is the thumb direction. But here the negative sign. The direction of V cross B is plus z. Direction of V cross B is what? Positive z. But this negative sign is present, so it means negative z. So by the using of right hand thumb rule, we get the direction of force on electron is in minus z, means it is towards the minus z. Okay, so force on electron is towards the minus z. You just write in this format. Force on electron is towards minus z direction. Simple way. Okay, similar way you finding out the second case, you just solve it. Force on proton, then Fm is equal to, जो proton में तो E plus होता है, then E into V cross B. Again use right hand thumb rule. Then only find the direction of V cross B. So V is along x-axis, B is along y-axis, and here this type of situation is given to you. Then V cross B upward. Upward means positive source, positive z. Then force on proton is towards पॉजिटिव जेड डायरेक्शन. आप ऐसा भी कर सकते हो या फिर आप ऐसा भी कर सकते हो, यहाँ पे एक्स वाई जेड डायरेक्शन में सब कुछ है. देन यूज द यूनिट वेक्टर, then write the fm in this format. That's another method. Okay, if you have to use, there is a simple one. That's always we have to use the right hand thumb rule because it is the easiest one. यहाँ पे कभी कभी आप मिस्टेक भी कर सकते हो, ठीक है, बट यहाँ पे चलो सॉल्व भी कर लेते एक बार. fm is equal to minus e. V is along x axis, so vi, and the b is along y axis, so cross BJ. So you have to finding out the direction. EVB को आप outside ले लो, minus I cross J. You find the direction of minus I cross J. I cross J is equal to K. I cross J is equal to what? K. So FM is what actually? FM is equal to EVB minus K. What is a minus K? Minus K means negative Z. Minus K means, so see, I cross J is a K, as we know. We already studied about the vectors. Okay, so at that time we finding out this I cross J. If you want to find, then you just using this triangle, using the circle I J K. If you move in a clockwise direction, use the positive sign. If you move in anti-clockwise direction, use the negative sign. Right now you want I cross J. So I to J clockwise, this means positive. And so the answer is what? K. So plus K. And the negative is already present, so minus K. Okay. So by this way you get the answer. So EVB, similar way, use the same one. V cross B is equal to what? I cross J. And that time plus K. So you write this method too by yourself here. Okay, so by this way you get the answer also, but it is only useful when the unit vectors are given to you. But this one is generally used when it is not given to you. So always use the right hand thumb rule to get the direction of the force by the using of right hand thumb rule. A very simple one. Okay, चलो पूरा example आपके books में अच्छी तरह से notes कर लो. Okay guys, comes to this next example. Example number 4.5 from the textbook exercise. What is the magnitude of the magnetic force per unit length? So we have to finding out the force per unit length. So force is equal to finding out, and L is equal to what? 1 meter. Means you can just find this F upon L. Actually you have to find F upon L is equal to what? आप ऐसे भी count कर सकते हो, ठीक है? Now this wire carrying a current of 8 ampere and making angle of 30 degree with the uniform magnetic field 0.15 Tesla. Means this type of consideration, thus supposed to be B, uniform magnetic field, and the wire is like this. So the angle is what? 30 degree. Some current is flow through it. So ideal making angle of 30 degree. So what is this magnetic force? Directly use the equation of this one. So magnetic force Fm is equal to ILB sin theta. Uniform wire means use this equation directly. ILB sin theta. What is I? 8 ampere. L, actually you find this F upon L. So Fm upon L is equal to I into B into sin theta. आप इसमें वैल्यू रख दो, आपका आंसर होगा, जो भी आंसर हो न्यूटन पर मीटर लिखना है. ओके, पर यूनिट लेंथ है. ओके, आप ऐसे भी काउंट कर सकते हैं. L is equal to 1 meter. So per unit length you get, our answer is like this. So put the all value, because B given, I given, theta, everything is given here. So put here, you get the answer. Okay, so calculation is in homework. So very simple example which is given in our textbook. So note करो example को. Okay guys, comes to this next example. Example number 4.21 from the textbook exercise. It is from additional exercise. So this is not a part of a board theory. Okay, we have to learn this example for the competitive exam, NEET and JEE. What is the problem statement? A straight horizontal conducting rod of length 0.45 meter. So length is equal to 0.45 meter. And the mass is 60 gram. So 60 into 10 raised to minus 3 kg. Gram is converted into kg. Suspended by two vertical wire at its end. Means this type of situation. Consider, suppose here the support is given to you, and this is the two wires, and the rod is suspended by the wire in this way. This is the rod is suspended in this form. Okay, so here what is this next one? What is given here? A current of 5 ampere is set up into the rod through the wire. So here consider, suppose some current I is flow through it. What is the I? I is equal to 5 ampere. And question is what is the magnetic field should be set up normal to the underline, normal to the conductor. So B is normal to the I. B is means theta is equal to 90 degree. Normal to the conductor. In order to the tension in the wire is 0. So first we have to find if tension is equal to 0, then B is equal to what? That is our first question. Now, what will be the total tension in the wire if the direction of the current is reverse, keeping the magnitude of the field is same as before? Ignore the masses of the wires and take G is equal to 9.8. So here the second problem is what? If B is reverse, then find new tension in the wire. Suppose we have to write the T dash. We have to write the T dash. So this type of situation is given to us. So first of all, what is this relation of the tension and everything? So here this supposed to be considered tension. Here it is also because two wires, so there is a tension is like this. Now this mg is somewhere here because mg is applied. Now we have to set up the magnetic field in such a way so that the tension becomes 0. Okay, so if you apply the another force in the same direction as the mg, then tension is never 0. You can apply this magnetic field in such a way so that Fm must be is opposite to this mg. Fm must be in opposite direction of the mg. Then and then only possible situation is tension is 0. क्योंकि अगर ये दोनों सेम हो गया तो फिर टेंशन 0 हो जाएगा. If Fm becomes equal to the mg, then T becomes 0. Otherwise it is not possible. So how we set up the magnetic field? So you arrange the magnetic field in such a way so that Fm is in upward direction. So I तो यही डायरेक्शन में, तो I यहाँ पे, तो थंब कहाँ पे आना चाहिए? अपवर्ड. तो थंब यहाँ पे आया तो फिर आपको इस डायरेक्शन में आपकी फिंगर, यूज द राइट हैंड थंब रूल. You curl your fingers like this. Okay, means magnetic field must be applied here in a into the plane, means horizontal. Right now this one, so a magnetic field is in a horizontal direction which is perpendicular to the conductor. So you apply the magnetic field in this way. Here you must be applied the magnetic field in this way. So first one is our, what is the first answer? Apply if tension is 0, then there is only one possibility. So apply magnetic field B in horizontal direction and perpendicular to road. क्योंकि perpendicular ही हुआ, road को perpendicular ऐसे आपको apply करना है. Okay, now what is this relation? If this you consider equilibrium, so in equilibrium, upward force is equal to downward force. So 2T plus Fm is equal to what? Mg. Upward force T plus T, 2T plus Fm is equal to what? Mg. Now you take the tension 0, then what is the B? So here you put tension is equal to 0 and find the B. So okay, so tension is equal to 0 plus what is the Fm here? Fm is the ILB sin 90, because एंगल कितना हुआ? I यहाँ पे है, B यहाँ पे है, तो एंगल कितना हुआ? 90. आप डायरेक्शन भी फाइंड देखो, I B तो अपर डायरेक्शन में फोर्स है, आपको अपर डायरेक्शन में ही चाहिए, तो आपको ऐसे आपका आंसर हो जाएगा. तो यहाँ पे लिख दो sin 90 is equal to what? Mg. Then what is this B here actually? So ILB is equal to Mg. So from this B is equal to Mg upon IL. This is your final answer. M given to you, I given to you, L given to you, and in this case you consider G is equal to 9.8 meter per second square. It is given in a problem. So आप डेटा रख के B फाइंड करो, ठीक है? So find B. This is in homework. ये कैसा हो जाएगा आपका? होमवर्क में एग्जाम्पल हो जाएगा. Now the second problem is what if the B is reversed? Then find the new tension in the wire. तो अगर B को रिवर्स किया तो टेंशन, तो एक फिगर आपको कैसे ड्रॉ करनी है? देखो इफ द B इज रिवर्स, B this type of situation, so current is same I. So now tension is what? Supposed to be considered T dash. न्यू टेंशन टी डैश, पहले तो टी को हमने जीरो रख दिया, इस बेस में तो टी जीरो था. सपोज यू कंसीडर द टी डैश हियर. नाउ एम जी इज इन द सेम डायरेक्शन, सो दिस इज एम जी, बट विच डायरेक्शन इज रिवर्स? बी. पहले बी कहां पे था? दस इनटू द प्लेन. नाउ यू कंसीडर दस बी इज आउट टू द प्लेन, बी इज कम्स आउट फ्रॉम द प्लेन, सो दैट इज द डायरेक्शन ऑफ बी. B is coming out from the plane. So what is the direction of magnetic force? So IL is in this direction. B is coming out from the plane. Okay, IL and B. Use the right hand thumb rule and find the direction of force. So arrange your right hand parallel to IL. So parallel to IL. Curl your fingers towards the B. Curl your fingers towards the B. So the direction is downwards. Arrange your right hand parallel to the IL. So IL is this one. Curl your fingers towards the B. तो B यहाँ पे है, तो आपका फिंगर का थंब कहाँ पे है? डाउनवर्ड डायरेक्शन, मतलब एफएम कहाँ पे होगा इस केस में? डाउनवर्ड. सो हियर वन अनदर फोर्स इज अप्लाइड एंड व्हाट इज दिस? विदाउट चेंजिंग द मैग्नीट्यूड ऑफ बी. सो बी को बी तो बी इतना ही रखना है, ठीक है. तो इस केस में आपका इक्विलिब्रियम क्या होगा? सो इक्विलिब्रियम 2t डैश इज इक्वल टू एफ एम प्लस एम जी. बट एफ एम एंड एम जी तो इस केस में सेम ही था. देखो इस टू, क्योंकि मैग्नीट्यूड तो चेंज ही नहीं हुआ. इसको कंसीडर करो. आई एल बी इज इक्वल टू व्हाट? एम जी. सो इसमें आपका आंसर क्या हो जाएगा? टी डैश इज इक्वल टू, अगर 2t डैश इज इक्वल टू आई एल बी प्लस एम जी इज इक्वल टू व्हाट? 2mg. क्यों? बिकॉज आई एल बी इज इक्वल टू एम जी. सो 2 कैंसल आउट. तो इस केस में आपका आंसर होगा T dash is equal to mg. Put the value of m and g and you get the final answer. So again, in this case, your calculation is in homework. आप इस तरह से प्रॉब्लम को सॉल्व कर सकते हो. If you just reverse the direction of the magnetic field, then the direction of force is also changed. Then your new equilibrium is just right in this way, and you get the final answer. Okay, so put the value and you get the answer by this way. So that is a quite different example we have to study here, and all of you guys must be write this example in your books properly, and this example is only for a competitive examination, not for the board examination. Okay, because additional exercise is not asking in a board theory. Okay, चलो नोट करो example को.